Hi guy, I'm Laurie from AI Elephant.
Hi guys, I'm Leo.
Welcome back. Leo, when we talk about AI, we mostly talk about language about GPT. But have you ever thought that for intelligence, seeing might be more fundamental than speaking?
Seeing? You mean computer vision? I thought that was just about cameras, recognizing faces, or tagging photos. Is that really more important than language? You need language to think, right?
But human intelligence began with perceiving the world even before language. Today, we read talking about a core idea from Professor Fei-fei's talk at NeurIPS. AI must move beyond the 2D flat Earth to climb the 3D ladder of spatial intelligence, ultimately making the leap from seeing to doing. Professor Lee's look back is fascinating. She mentioned the first light 5.4 billion years ago, when the simplest organisms on Earth first evolved light. Sensitive cells, the evolution of vision and intelligence became deeply intertwined.
5.4 billion years, that is a bit of a large-scale lapse. So what was the Northstar Problem for AI vision? It can be evolving light? Sensitive cells, can it?
Laughs, of course not. In the early 2000s, AI vision was very primitive, dealing with toy problems. Inspired by neuroscience, they identified the North Star, object recognition.
I get it. Like how a baby first learns to recognize mom or bottle before they can understand the complex world. But AI couldn't even do that back then.
It couldn't do it well. Psychologists say a 6-year-old human can recognize tens of thousands of object categories. Back then, datasets only had a few dozen categories. The key bottleneck was generalization, and that meant data.
And so, the famous ImageNet entered the scene.
Yes, ImageNet in 2009. Its goal was to reboot neural networks using massive, diverse data. By 2012, AlexNet won, and the modern AI revolution was ignited. It was a convergence of many forces: algorithms, GPU computing, and big data. From then on, data was proven to be as important as algorithms. Once AI basically learned to understand pixels, it began to move to higher levels: reasoning and generation.
Reasoning I can sort of get. It is not just seeing a person and a chair, but knowing the person is sitting on the chair, right? Is that the scene graph thing?
Exactly. It could even do zero-shot learning, inferring unseen scenes like a person sitting on a fire hydrant. This was driven by large datasets like visual genome.
Well, the progress in generation is even more obvious. I remember maybe 6 years ago, those AI-generated pictures were all blurry and weird, a bit like nightmare fuel? Laughs?
Laughs, they were very blurry. Early methods used GANs and VAEs, and the process was complex. But now with transformer-based diffusion models, we can already generate high-quality video.
That leap is astonishing. But isn't that the end goal for AI vision? It can make videos.
No, Professor Lee raised a critical warning. All of our achievements so far, including the most powerful LLMs and multimodal models, are essentially confined to a flat Earth.
Flat Earth! Another metaphor. Aren't T2D images and videos how we perceive the world? What is the limitation?
The limitations are huge. Language is inherently generative, but perception has an object, the physical world, which is physically there. In a 2D world, AI cannot truly understand the laws of physics.
Still a bit abstract. Give me an example.
The famous checkerboard illusion. The human brain produces this illusion because it has a built-in understanding of 3D space, light sources, and shadows. An AI looking at the 2D image struggles to grasp this. Professor Lee used Plato's allegory of the cave to describe this challenge. We all live in a 3D world, but we and AI only see its 2D projections on a wall. We must infer 3D from 2D.
I see. So that is why AI-generated images have those weird artifacts, like extra fingers or physics, defying shadows. It doesn't understand 3D space.
Right. And it is why MLMs perform far worse than humans on 3D reasoning benchmarks. AI must climb the 3D ladder of spatial intelligence.
For example, using NeRF neural radiance fields combined with diffusion models to unify 3D reconstruction and generation.
Like that Zero MVS, which can reconstruct a 360-degree scene from a single image. That sounds like it is starting to truly understand space.
Yes, that is the leap from the 2D flat world to the 3D physical world. Why obsess over 3D? Because the ultimate purpose of evolution is interaction. It is using perception to do things.
Finally, robots. Laughs. I just want to know, why do we expect robots to cook and do laundry when my robot vacuum is still so brittle and always gets trapped by a charging cable?
Laughs because robotics research is also missing that key ingredient, data. The real world is ecologically complex. We've been training them in labs on hand-picked, simple tasks.
So, we need an ImageNet for robots?
Exactly. Professor Li's team introduced the behavior, Benchmark, which simulates 1,000 daily household activities in a virtual environment, and Object Folder, which collects visual, acoustic, and tactile data from objects.
I also saw a term, digital cousin, instead of digital twin. What is the distinction?
It is a very smart concept. A twin requires an exact, costly replica. A cousin doesn't need to be exact. It just needs to preserve similar geometric and semantic affordances.
Oh, so the robot doesn't need to recognize my specific hammer. It just needs to recognize hammer, like objects to learn how to hammer. That allows for much better generalization.
Correct. And even further, because robot data is so hard to get, researchers are using the knowledge from LLMs and VLMs, like VoxPoser, which uses an LLM to help a robot understand complex commands with no training, like open the top drawer and be careful of the vase.
Now, that is a true virtuous cycle of seeing, learning, and doing. Laurie, after hearing you describe this future of 3D intelligence and robotics, I am honestly a bit more anxious. Wry laugh. Isn't this just robots stealing jobs? The fear of replace is very real.
This was the final, and most important, call to action in her talk. She argues that we, as researchers and as a society, must replace the verb replace with augment.
Augment? Isn't that just a nice way of spinning it?
She gave the example of healthcare. In the US, more people die from hospital-acquired infections than from car crashes. What can AI do? Use depth sensors to monitor 24/7, ensuring doctors and nurses comply with hand hygiene protocols.
That is saving lives. That is augmenting the healthcare system, not replacing the doctor.
Exactly. Or helping to assess ICU patient movement or the independent living status of seniors. She even showed the ultimate form of augment, using non-invasive EG to allow a completely paralyzed patient to think and command a robot to cook for them.
That is restoring a person's agency.
Right. It is the same in the creative fields. AI isn't replacing creators. It is giving them tools to generate navigable 3D environments from text prompts and keyframing precise camera movements.
I get it now. AI is a tool. Its purpose is to unleash human potential, not to replace us.
So, the ladder of visual intelligence is about climbing from 2D understanding, reasoning, and generation, up to 3D spatial understanding and generation, and finally, to interaction with the physical world through embodied AI.
And throughout this entire process, the mindset we should choose is that of AI as a powerful tool here to augment our abilities in medicine, creativity, and daily life.
From seeing to doing, AI is just beginning its climb. Thank you for listening.
We'll see you next time.